Here's more.
From the depths of the fog, an unusual shape appears at the mouth of the Ems River. From afar, it looks like a steamer with 4 smokestacks. But it's not steam-powered. It's the E-Ship 1, and it relies on the power of the wind. This one-of-a-kind cargo ship actually sails. Rolf Roden is the project manager and chief design engineer for the E-Ship 1.
They're definitely not ordinary sails in the traditional sense. They're actually machines that use wind energy to propel the ship forward. It's still sailing, but you could call it active sailing instead. That's what we call it.
With their unique design, the E-Ship 1 engineers made use of a phenomenon called the Magnus effect, named after Heinrich Gustav Magnus, who first described it back in 1852. Electric motors set the 4 rotating cylinders, known as Flettner rotors, in motion. On one side, the wind is accelerated, and on the other, it's decelerated. The difference in airspeed creates a pressure differential, according to the laws of flow dynamics. That air pressure difference, in turn, provides a force perpendicular to the direction of the wind flow. The E-Ship 1's Flettner rotors use this remarkable effect to propel the ship.
It's essentially the same as an ordinary sail or an airfoil. On the top, the stream is accelerated, and on the other side it's not. That produces a difference in airspeed. Traditional sails or airfoils generate that difference passively, just due to their geometry, but we actively produce the speed difference by powering the cylinders.
That power comes from diesel generators. They use only about 5% of the energy that a normal ship's engine would. Each of the 4 cylindrical rotor sails is 27 meters high and 4.3 meters in diameter. The cores are made of steel columns surrounded by aluminum.
We can see the standing part. It ends here. The support column is made of steel. On top, we have the main bearing, and the propulsion system sits right here below. It's connected by the shaft to the steel hub here, where the aluminum rotor is screwed on. Its entire weight is resting here. This is where the rotation motion begins. It goes on down to the deck, and then another 10 meters to the top.
But the rotors are only one part of the ship's innovative design. A sophisticated control system makes for a smooth interaction between the rotor sails and the conventional marine diesel engine.
We're not just a sailing ship, we're a motor sailing ship. That is, the main propulsion system is optimized to work together with the sails in a practical and efficient way.
When they designed the ship's propellers, the engineers relied on their expertise from working on wind power facilities. The steering gear was fine-tuned to accommodate the sails.
The ship has to be easy to navigate when sailing. Basically, we can turn off the main propulsion system when the wind is good. If we do that, we have to maintain a large rudder control surface to deal with the transverse forces coming from the sails.
The ship's sleek lines were designed to create as little air and water resistance as possible. The novel wave breaker at the bow was tested extensively in water channels. And the smooth layer of silicon-based paint also helps make the ship more energy efficient. E-Ship 1 can transport up to 20 wind power facilities. It's specially designed to lower cargo costs, cutting fuel costs by 30 to 40%.
Everything was specially crafted so the ship can save as much energy as possible. Potentially, its energy use is half that of a conventional ship. We'll see over the course of the coming months and years how much of that potential we can actually exploit. At that point, we'll have concrete numbers that everyone can use.
International cargo shipping consumes about 280 million tons of oil every year. But with the power of the wind and innovative design, that's set to change.
Chocolate is bad for you, right? Wrong, at least according to one